Hi, Amy. How are you doing?
Hi, sir. I'm good, thank you. How are you?
Very good, very good. So uh, now you are in year 13 and you want to review right from the very beginning so that moving forward there is no problem, correct?
Right, yeah.
We did had one lesson on functions. Functions is the base as we discussed. So we'll move forward today and we'll do inverse of a function and transformation of functions.
All
Okay?
right, okay.
Yeah.
Yeah.
That should cover major portion of your unit 2. And after this, you should do some questions from your book and also GCSE actual test papers, right?
Yeah.
So in
Yeah.
case you have any difficulty, ask me. We can discuss those next time, and then we'll move forward from this to the next unit. Perfect.
Sounds good. Yeah.
Okay. So let me share with you the screen, which will help us go through. Okay. So you can see the screen, right?
Yes, I can.
Transformation of functions will begin from here. We know what a function is. So basically, what a function is that for every input, we have one output. So every input is assigned one unique output, correct?
Yeah.
Now, many of these inputs could be assigned to just one output also, right? For example, a horizontal line we understood is a function where many x values are just assigned to only one y value, y
Yeah.
equal to constant k, for example, correct? But normally, we have one-to-one relations. Now, one-to-one relation is the one where each and every input is assigned to exactly one output, and every output is assigned to one input, correct? So
Mm-hmm.
that is one-to-one relation. In a function, we do have one-to-many relation also. For example, in a parabola, we saw that minus 2 square is 4, and 2 square is also 4, correct? So
Yeah.
the two values here are assigned to just one value, 4, correct? So this relation is where many are assigned to one value in y. So we'll call it a many to one relation. Right? So these
Yeah.
are both functions. However, there is some difference between the two, which we'll see while doing inverse of a function. Correct? Now let's first begin with the transformation of the function. Transformation, the formula is given to you right here in the center. G of x is equals to a f of k times x minus p plus q, right? Do you see this formula right in the center?
Yeah.
So here we are actually transforming the function k, f of x. So when we discuss transformation of function, we take one as a parent function or the original function. So
Yeah.
normally we will consider f of x as our original function and g of x as the transformation of that function. Perfect.
Yeah.
Now, if you see, I've made square brackets, f of square brackets. Do you see that part? Now,
Mm-hmm.
whatever is within the square bracket actually leads to horizontal transformations. That is very
Oh,
important to understand.
okay.
Whatever is outside the square bracket leads to vertical transformation. Right? So
Oh,
that helps us to sort out a major problem of thinking whether it's a vertical stretch or a horizontal compression. You get the idea. It's a
right. Yeah,
very
yeah.
common question asked. So let's begin with the center. Always working with functions is good always to begin with the center. So the value of k, in the center, things go in the reverse direction. The value of k, if it is greater than 1, in that case, it is actually a horizontal compression. So I've written here absolute value of k, right? So we'll not consider negative sign. Negative sign means a reflection on the y-axis, right? So if it is negative 5, for example, then the negative value represents the reflection on the y-axis. You get an idea. So let me just
Mm-hmm.
make a small sketch here. We'll take up an example. For example, if I have a square root function, which will be kind of like this, in that case, if I have k value, which is, let us say, 2, right? So in that case, I may have a graph which is square root 2k, right? So if I have square root 2k, in that case, what really happens is that the graph gets compressed horizontally. You compressed horizontally means if this is a point here, it will go halfway. Do you understand?
Mm-hmm.
So, so the value, let us say this is 4 and square root of 4 is 2. But if I have 2k, then the graph will actually move kind of like this. Do you see this graph coming?
Yeah.
It is
Or steeple.
horizontally compressed. You understand? So this is what we mean by saying horizontally compressed. So now actually speaking, you'll get 2 at the value of x being 2, right? Half the value. Get the idea? You
Mm-hmm.
can check it out that if I put, sorry, this is x, not k, the k value being 2. So if I write 2 times 2, right? Do you see that? Then the
Mm-hmm.
square root is 4, and which gives you the same result at 2. So you notice that if k value is greater, then it gets compressed, right? So
Yeah.
horizontally, as shown here, the point moves left, right? So that is compressed. Many times we have questions where a restricted domain is given to you. The whole domain will get, in such case, compressed by a factor of half.
Oh,
You get the
I
idea,
see.
right?
Yeah.
Those could be some tricky questions. So you understand why? Because sometimes you feel 2 is greater than 1, it is probably a stretch. No, it is a compression, right? It does give you a look like a vertical stretch. It's kind of, you could factor out 2 outside, you'll get square root 2, which leads to vertical stretch, right? That's a different story. But when it is inside, you have to say that it is horizontally compressed by a factor of half. You get the idea?
Yeah.
So we'll say horizontally compressed by a factor of, I should write 1 over a, 1 over a, okay? So it is 2k, it is horizontally compressed by a factor of 1 over k, I should have written, but anyway, if it is a to k, okay. So we are saying that the value is a, but it is, let me write k here. 2. Correct. But if it is less than 1, in that case, it is horizontally compressed, but still by a factor of 1 over k. But since, let us say, it is half, for example, if I take a value of k as equal to, let us say, half, in that case, what happens? In that case, let me write it in a different ink so that you can see it. If k is equal to half, right? In that case, the function will be square root of half x, correct? So that means horizontally we'll stretch this point to the right and the graph will look like this. Do you see that part? So that
Yeah.
orange part kind of
Mhm.
stretches, right? Do you see that? That is, you got to multiply the value by 2, right? To get this point moves 2 units, which was at 4, now will come at 8. Do you see that?
Yeah. Yeah.
That's the whole idea. And makes sense because half of 8 square root, if you do, is basically square root of 4, which will give you the same y value as 2. Is this part clear to you?
Yeah.
Perfect. So that is as far as horizontal compressions or stretch is concerned. If the value of P is positive, this means translate horizontally. If P is greater than 0, it is translation to the right. If P is less than 0, it is translation to the left. Correct? Now,
Yeah.
as I'm saying, K, there could be a negative number there. So if the value of K, which I'm writing here, I should have written K. If K is less than 0, then it is a reflection on the y-axis. Is that clear to you?
Mm-hmm.
Perfect. Now, let's look into the outside parts, which are vertical stretch and vertical translation. The value of A, if it is greater than 1, it means a vertical stretch by a factor of A. And if it is less than equal to 1, equal to 1 doesn't really make sense, then in case it will be compressed by a factor of A, correct? If A is negative, in that case, it is reflected on the x-axis. Perfect. So we'll take up
Mm-hmm.
examples to elaborate on this. On the other side, Q, if it is positive, in that case, it gets vertically translated up. If Q is negative, it goes down by those many units. Clear?
Yeah.
Now, image point. If on the original function, we have an image point xy, in that case, what happens to the image? I mean, the original point is xy, then what
Mm-hmm.
happens to this as an image on the transfer function? As an image, we see that the value of x will be divided by k and then translated p units to the right. That means we'll add p, correct?
Yeah, because we're going to the right. Yeah.
Right. And as far as the vertical stretch and translations are concerned, we are going to multiply the value by a and add q. So the point will get translated as shown here. So that becomes your image point. Clear?
Yeah.
So let's move on and take up some examples. So in the very first example, we have a very simple function y equals to x square, right? So y equals to x square is the function given to you in green, right? So this is your y equals to x square function in green. We have translated this function. Can you tell me the transformation on this particular function?
Um, can it be two things?
Yeah,
So can you go down? Okay, go across and
both.
then down. Yeah. Can
Either.
you go down and across either as well?
Same thing.
Okay.
So you could actually go down and
Is it 3 units or no? 4. Yeah,
okay.
4 and then 5.
Correct, 4 units, right? So
Yeah.
in that case, because it has gone down, okay, so y will be equals to, we don't know the stretch factor yet. So I'm writing, let me write here. So y equals to a times, but we know that horizontally, I have moved 2 units to the right, correct? So that means
Minus.
minus 2 whole
Yeah.
square. And I've gone down by 4 units. That becomes my equation to begin with. Now, we need to figure out what is the stretch factor. That is kind of complicated. We know the point 0, 0 is on this curve. You could see any point, right? 5, 5 is also on this curve. For example,
Yeah.
right? Read a point from the graph, substitute that value. 0, 0 is a good value. So let's write 0 for y value and 0 for x, minus 4. So what we get? 4 comes on
Um,
this side and we get 2
4
square, which
minus
is
4.
4a, and therefore a is equal to 1. So in this case, there is only translation, no stretch or compression. You see that?
A
So we
equals
get the
1. Yeah.
graph as y equals to x minus 2 whole square minus 4, correct? So we
Yeah.
get a graph which is only translated, right? Now, from the graph also, we could have seen that there is no compression or stretch on the graph since the graph is congruent. Do you see that part? Both the
Mm.
graphs are congruent, right? If I overlap this red on the green part, you will notice that they will, match each other. Is that clear to you?
Yeah. Yeah.
So that is how we could actually see uh, that it is better to try to find the value of a, but at times you could also see they are congruent. There is no need to find the value of a, right? This is what I wanted to emphasize with my first example. Is that clear to you?
Mm-hmm.
Well, here is the working of the same, so that's fine. Let's take the next example. Now, in this particular case, the green graph shown to you is the graph of square root of x. Take it
Yeah.
as a question. Tell me, what is the equation of the transformed graph, which is the red one? And how can you quickly find? The idea is we have to quickly find the result. How can we do it quickly? Tell me.
Okay. So there's been a horizontal translation to the left. So it will be like root x minus 1. And then because it's a reflection in the x-axis, a would be negative, or like minus
Okay.
minus f of x.
Yes. So we see the origin actually gives us the translation perfectly, right? We have seen clearly from here, there's only horizontal translation, correct?
Yeah.
And so we got a
Oh, are we
point.
doing green onto red?
Yeah, green to red.
Oh, sorry. Yeah, I meant +1.
Yeah,
Yeah.
that's correct. Green to red. Now, you could have written minus. You may not write minus. It's up
Oh,
to you, right? So
okay.
I know this is negative. So I'll keep that as a checkpoint. You get my point?
Mm-hmm.
If I do not get minus value of a, I mean, I know that I've done some mistake. You get the idea?
Oh, I see.
I
Yeah,
know
yeah.
a is negative. I'll keep just a. I'll not make it negative or positive. Is that okay?
Okay.
So now to get the value of a, I have to find a good point on the graph. So this point is a good point. So I'm saying, well, the y-intercept is minus 3. So I'll substitute this value. So x is 0, y is minus 3. So I'm saying minus 3 equals to a times square
A
root of 0
root
plus
1
1, which is a, right? So clearly I got a as minus 3. If you
minus
see that?
3.
So my equation is y equals to minus 3 square root of x plus 1. You see that there is a vertical stretch.
Oh,
There is a vertical stretch since they are not congruent. Do you see not congruent?
yeah, yeah.
So with these two examples, we have understood many things. They are very simple examples, right? but they
Mm.
give you insight to transformation. Congruent means you need not find A, just put it one and go through it, right? But
Yeah.
clearly, if
And
you are seeing there is a stretch factor, you have to find the value of A. Yes, please.
right.
Yeah.
Oh no, I just said that like you said, don't make A as, even though you know it's gonna be negative, don't write like -A, because then that
Important.
means I'll get it as 3 instead of -3, and then it will be wrong. So yeah.
So you know it is A value has to be less than zero, correct? Let it be a
Yeah,
checkpoint.
yeah.
Let it be a checkpoint. Do
Okay.
your calculations in the exam. You may go wrong, but you know it is
Yeah,
negative,
yeah.
right? So check your
That's
calculation.
true.
Right. So that is why we will not do it. So here is the solution of it, which we have already got. I've taken now another function. So we are just going through most of the parent functions, which you will see in your test papers. So we have 2 to the power of x as my base function. So in this particular case, the black graph here is 2 to the power of x. Red is the transform function. Can you tell me how will you figure out this transformation?
Wait, was this the one where it was a horizontal stretch?
So we have to look into the critical points, right? So for a function which is an exponential function, 0 1, the y-intercept is a very critical point. Do you see that part, 0 and
Yeah.
1? We clearly see that that point has moved to another point, which is 1. At 2 we get that value of 1. Do you see this point is
2, 1.
2 1, right? So what we are looking at is this thing. Second, we should also look for some other point on the graph, right? So this is another point which is a good point here. Let me write this as 5, and the value for this is 6 7 8. Do you see that? 2 points. Is that clear
Yeah.
to you?
Uh-huh.
So we got this. Now when we have reciprocal function or this kind of exponential functions, remember one thing, that it could be a horizontal stretch or compression, or it could be vertical stretch or compression. Is that clear to you?
Yeah.
Finding horizontal stretch or compression is very difficult, and therefore
Mm.
assume that everything is vertical stretch or compression. Is that clear to you?
Okay.
So we'll write the function y as equals to, thinking that this is to be a, right? 2 to the power of x minus p plus q. Do you understand now? So in general, we'll think like this, that there is only horizontal translation, no stretch or compression. So my general equation of transformation will be a times 2 to the power of x minus p. Is that clear to you?
Wait, x minus p.
P,
Okay. Okay.
p
Yeah.
is my horizontal translation, right?
Yeah.
And q is my vertical translation. And stretch
Yeah.
and compression or reflection,
Is
well,
a.
a. If this would have been the
Oh.
other way, I would have taken minus x, of course, right? If it
Yeah.
was on the x. So I have to. Now I have seen that this graph has the same horizontal asymptote. So Q value is 0, right? So we know Q is 0, correct? So
Yeah.
basically, we have A equals to y equals to A 2 to the power of x minus p. Is that clear to you?
Yeah. Because the q is 0. Yeah.
Correct. Now we got two unknowns and 2 points we can figure out. We can substitute these 2 points and solve our equation. That is probably the best way, right? We'll come to a
Oh.
quick solution also. So first point is 2 1, then 5 8. We got 2 points, right? So when I use the point 2 1, that means 1 is the y value and 2 is the x value, right? So 2 to the power of 2 minus p.
2 minus p.
The other equation is 8 equals to a 2 to the power of 5
8
minus p, right?
minus p. Yeah.
If I divide one equation by the other, in that case, a and a will cancel. Do you see that?
Hmm.
I could write this as, I'll write 8 on the top, right? Y to, and I'll write 2 to the power of 5 minus p, correct? Minus of 2 minus p. Is that clear to you?
Um. Wait, did you just divide?
Okay, let's go again. Let's go again. Let's go again through it. Okay. So let us say, let us assume for now that this particular point has moved 2 units to the right, correct?
Hmm. Yeah.
Now, if you think that this has moved 2 units to the right, that means you are taking that the horizontally it has been stretched by a factor of,
1/2.
yeah, because it is horizontally gone there, right? Do you
Yeah.
understand?
Yeah.
1/2. You could think like this also and then solve this particular equation, right? Is it clear to you, right?
Yeah, that's
You could
clear.
do it. Right. Okay. And you also notice that the y-intercept is much below, right? That means you could also think that the vertically it has been compressed. Vertically it has been compressed because you could think two ways.
Oh,
Either
because
you
the
could think
y-intercept has gone down.
y-intercept has gone down. So you could think
Got
that
it.
it's vertically compressed, right?
Yeah.
Or you could think that it is horizontally stretched. Both are one and the same thing. Is that clear to you from the graph?
Yeah. So both of those things have happened to the graph.
Both, yeah. But can't
Okay.
put everything on one side. Think that it is only in this case. Let us think it is only because this value is very accurate. You understand?
Mm.
It is 2, very accurate. Since it is very accurate in this case, I'll say my function y, I'm not putting anything on the vertical side now. I'm putting
Okay.
everything as 2 to the power of, we know the x value should be half of x. You understand?
Yeah.
But we don't know what is my translation. Is that clear to you? Because
Why is it not
we have
2?
contributed that point to a horizontal stretch. So I just pulled it, but we don't know how much we translated.
Oh, right.
We know
Yeah.
vertically it is 0.
Yeah.
Correct? Because the horizontal asymptote is still y equals to 0. Do you understand?
Hmm. That
So when
hasn't
you are
changed.
looking into how do we write equation, you have to think in many different ways.
Mm.
So this time, now we will use the 0.58, the second point.
Okay. And then sub them in.
Sub them. So 8 equals to 2. Is it 5? Yeah, 5 and 8.
Yeah. 5
2 to the power of
my
half,
half of
5
5
minus
minus
p.
p.
Right. Correct.
Oh, is it p?
Oh, sorry, p here. Yeah, 5 minus p. 5 is the x value.
Yeah.
That is what we have. Right. So now we know 8 is 2 to the power of 3. Do you see how? Or you'll use logarithm. Do you
Oh,
understand? 5
yeah.
minus p. So
And then
in
make
this
the
step,
exponents equal to each other.
3 equals to half of 5 minus p.
5 over 2
6
minus 2 over
equals
2.
to 5 minus p, right? So
Yeah.
p equals to 5 will go on this side, or you can say 5 minus 6. Is that okay? So p equals to minus 1. Is this clear to you?
Mm.
And therefore, we get the equation which will be y equals to 2 to the power of half x
X plus
plus
1.
1. You get the idea.
Oh. Mm-hmm.
Very difficult question.
That was quite hard. Yeah.
Looks
I
simple.
think it's because of this whole horizontal stretch thing, because it's 1 over. So that's the part that's hard.
So if you notice there is a horizontal stretch or a compression and you cannot replace it by vertical stretch or compression because you cannot
Yeah.
read that value. You understand?
Yeah.
It is, we don't know whether it is like half or 1/4 or what it is.
Oh,
Since
okay.
we
So do
cannot
I
read
have
it,
to find a point where it's readable exactly, and then
yeah,
from there I
readable.
can
Yeah,
judge
otherwise you'll get
whether
a
it's
wrong
left?
answer.
Okay.
So since we could not read it, we had to go for horizontal translation and stretch. Correct?
Yeah, makes
And it
sense.
makes things very complicated. But there's no other way.
Yeah.
So that could be a question in your test. It's a very good question. Now you could verify the result, right? So if you put all this, half of this, now you see, we have a 0.5. If I put 5 here, 5 plus 6 is 5 plus 1 is 6, right? Half of
5
6.
plus 1. Yeah.
You get the idea, right? So let's put 5 there just to verify, right? Y equals to, we are saying 2 to the power of half of 5 plus 1, correct?
Yeah. So 5 plus 1 is 6. 6 times half is 3. 2 to the power of 3 is 8.
Yeah. Do you see 8?
So it's right. Yeah.
So we have confirmed that our result is perfectly fine. Is this clear to you? Very, very important question. Correct?
Yeah, very clear.
So we
But
have
hard.
seen we have seen the translation. Well, this is the working of that particular. There's another one now, right? Maybe this is a different one. I don't know. Question number 3. I'd like you to look into this question later, right? So just I don't want to get into the solution of this now, but let this be an exercise for you. Okay.
Okay.
Seems to
Yeah.
be no. It is the same question. I think the same question, right? Okay. Here's the 4th question. This is different. So here you see that there is a vertical translation, correct? Because the horizontal asymptote has moved 2 units down. Is that clear to you?
Yeah. So from 0, it's gone to
And you can also clearly notice
2.
that the y-intercept has come down, correct?
Yeah,
So
yeah.
now we can, and it has, the step was 1 here. Now the step is 1, 2, 3. Do you see that 3?
Mm-hmm.
3 means from here to here 3 times. Earlier it was 2 times, 1 time. Do you see that?
Mm-hmm. Yeah.
Now I can write this as y equals to minus, because it has gone down 3 times, right? We know it is 2 to the power of x. I'm not putting anything k factor is x,
Yeah, yeah.
right? I could put, since I'm assuming the same thing, so I've taken the stretch here, I know that p is 1 because that is my y-intercept, correct?
Mm-hmm.
Horizontally, we have moved 2 units down, so I'll put it minus 2 here. Is this clear to you?
Yeah, yeah.
So I straight away get my equation. In case of vertical translation, it is very easy. You can straight away get the value, accurate.
Mm.
You get the idea?
Yeah, so it's looking at like asymptotes and points.
Yes. So we
Yeah.
looked at this asymptote, which is y equals to minus 2, and this y equals to minus 2 relates to the translation. Is that clear
Yeah,
to you?
moving 2 units down. Yeah.
Yeah. And this difference, which is 1 and this time it is 3, between the asymptote and this reflects to the factor of 3. And of course, there is a reflection on this side, correct? Which is because of the negative sign
Yeah. Yeah. Because it's reflected in the x-axis.
in the axis. So that is how vertically, if it is there, it is very simple and you can easily get it, correct?
3
Ah,
things have happened in that one.
hmm.
A lot.
Yeah,
Yeah.
yeah. And
Got
quick one,
transformations.
quick solution. You have to write domain and range for these functions, correct? We know the domain is all real numbers and the range is, it is less than minus 3, correct? So be clear about domain range, because many
Okay.
times those will be your, part A, B, C, D questions of all this, right? So we got this equation already. So we'll move on to the next type of function, which is reciprocal function. They are also very tricky functions. So the green graph is the graph of the original function, which is y equals to 1 over x. So this is your green graph. Is that clear to you? This point here.
Okay.
Now the red graph is the transformed graph. Correct? Now here,
Mm-hmm.
how do we get the transformations? Well, the key is to look at the
Asymptotes.
asymptotes. Correct. So what we see is that the vertical asymptote has moved 1 unit to the
One
right.
plane. Yeah.
1 unit to the right means it is a horizontal translation, right? So we could write 1 over x
Minus 1.
minus 1. That part we are clear. We don't know what
Yeah.
is a, right? So we'll write a here, correct? It
Yeah.
hasn't moved up and down, so that is it. Is that clear to you?
Yeah, because the y equals 0 is still the horizontal asymptote for both.
Correct. You're right.
Yeah.
Otherwise, if it would have
It would
moved,
be a
we would have
vertical.
written that here. Is that clear
Yeah.
to you?
Yeah.
So there's no need to write that. Now we know a point here. And this point you can read from the graph as 2, 2.
2,
Right?
2.
2, 2. Substitute 2, 2 here. 2 a over 2 minus 1. So a is equals to 2, right? So we get y
Mm-hmm.
equals to 2 over x minus 1. Is that clear to you?
Mm.
Easy. So identify the right point
Oh,
and
okay.
the asymptotes to get the result. Sometimes, most of the time, for your test, the points will be marked just as I have shown. Is this
Oh, okay. Yeah, I was just about to ask that. I was like, give the points or do we have to find them? But if we have to
otherwise?
find them, always find them literally
Exactly.
perfect.
Exactly.
Exact. Yeah.
Yeah. So that is the solution, right? We just got it in no time. Perfect. Now here's another function. You need to now work on this and tell me how will you find the equation of this particular graph. So looking at the
Mm-hmm.
graph, well, they will also tell you we have transformed the function which is f of x equals to square root of x, right? And that has
Yeah.
been transformed. Red is the transformed graph. We need to find the equation of the red graph. How will you do it? Tell me, please.
Okay, so it's been horizontally translated to the left by 1 unit. So
Mhm.
it's going to be root x plus 1. But then it's been reflected. Oh, the
Okay,
coordinates of
well,
that point is minus 1, 2.
yeah,
And then it's been reflected in the x-axis.
yeah,
So there would be a minus
correct.
root x plus 1.
So we'll straight away write a. We'll calculate a using one of the points. And within the square root, as you correctly said, it has moved left. That means x plus 1. And it has moved up by 2. Is that clear to you?
Yeah. But as you can
Value.
see, when
Hmm,
you put the red graph on the green, it's not congruent, so you know there's going to be some other
correct.
factor playing.
Stretch.
Yeah,
And that we'll put on vertical side. Because
yeah,
you have seen working on horizontal side is very difficult.
yeah,
On
yeah.
vertical, easy. We know the y-intercept very clearly, 0 and -1, right? So this point is very clear to us. We'll just substitute
Sub it.
-1 here, right? A, 0 plus 1 here, plus 2, correct? Bring
Yeah,
this here. So 1 equals to a square root,
one.
sorry, I mean -1 minus 2, right? So -3 is equals to a. Is that okay?
A. Yeah.
So we expected a negative value. We got that. And so we write y equals to -3 square root of x plus 1 plus 2. Is that clear to you?
Mm-hmm, mm-hmm. So
Very
if
easy.
I
Yeah.
so if it was a horizontal, so instead of thinking horizontal, always put it as a vertical because it's easier
Yes.
to deal with A than 1 over A. But if we get our answer as 1 over 2, then we know it's a horizontal. Is that what you're
No, no,
saying?
no. 1 over 2 will be vertical compression. This is
So how
vertical
do you
stretch.
know if it's a horizontal compression?
No, like we had very clearly seen that, it moved. That graph
Yeah.
actually got stretched, So you will see that.
Oh,
So
okay,
I
okay.
could have drawn this graph in a way that, for example, I could pull this point here, correct? And then draw a graph here. Do you see that graph?
Yeah.
So this graph, and if I give you this point, it means very clearly that it has been horizontally
Horizontally. Yeah. Okay, cool.
compressed. Then you
Yeah.
have no other option because I given you a point and I forced you to use that particular point to give me the
Oh,
answer.
I see. Yeah, yeah. And then if you did it on the other side of the green line, it's a horizontal stretch.
Yes, yes.
Okay, cool.
If I move this point instead of 1, I'll take it to 3, for example, correct? So let me
Yeah.
just draw another with another color and I could draw like this. Is that clear to you?
Yeah, yeah. Then I have to use
So
that point. Yeah.
horizontal stretch, and if I move it up or down, left or right, then the point to begin with, the origin, where the origin moves, will give you the translation, up or
I
down,
see.
correct?
Yeah.
So first, see the origin. How did the origin move, right? And
Okay.
that gives you the translation, P and Q values. Is that clear to you?
Yeah, yeah.
Then you identify a point and find the stretch factor, whether it is horizontal in your case or vertical in your case. If
Okay.
you have a choice, try to put vertical.
Yeah,
Easier
because it's
calculation.
easier. Mm-hmm.
Is this part clear, right?
Yeah.
I think there are many examples, but we'll stop here, okay? So, yeah, so we'll stop here. There are more questions here. I'll discuss these questions with you sometime later, but let's look
Okay.
into you can have a look at this question, right? So, this is the solution for that question. So, try to look at the question and answer it. Here's another question. Now we are focusing more on domain and range rather than sketching the graph. So, in the
Okay.
first part, we were focusing on how do we get the equation from the graph, correct?
Right.
Now it is a question of domain and range, correct? So you can figure out domain and range. For reciprocal functions, you clearly know that x is not in the domain and x equals to 0 is not in the domain. 0, 0 is not in the, like that, both the lines.
Yeah.
So from the translations, you can easily write down domain and range of a function. Right? So these are simple multiple choice questions for you to practice. Is that clear to you?
Mm-hmm.
Okay, so you can just go through some of these questions later, right? So I'm just going through them. Okay, with the solutions. Here is a question, for example, sine curve, right? Sine curves are restricted on both range and
Minus one and one.
minus
Yeah.
1 and 1, the range part. So when the shift is there vertical, then the range will change, correct?
Change. Yeah.
Right. The domain is all real numbers unless and until I give you restriction in the domain original function, there is no problem, right? So here's another function. I like you to work on these type of questions later. Here,
Okay.
what we are saying is, can you please read this question? This is interesting.
Yeah. So the point 2, 6 is on the graph of y equals f of x.
Mhm.
Determine the coordinates of the image of this point on the graph of g of x, which equals half of f, square brackets, minus 2x plus 1, square brackets, minus 5.
How will you do this type of question?
Okay, so you said to always start with the inside, with the horizontal inside the square brackets,
Yeah, okay.
right?
So transform.
So if we're at 2, 6, we have a
Okay, first we'll write the image points, okay? So if x, y is
okay,
any general point on the original function, then what is going to be my general image point? Then we'll do the calculation. Is it okay?
Oh,
So
okay. Yeah.
minus you, as you're saying, will divide this x, right? And then that plus means minus 1. Is this clear to you? So that becomes the x value. Is it clear? And the y coordinate will be multiplied by half, and then we take away 5. Is this clear?
Yeah, yeah.
So that becomes your coordinate point. Now, since we are given 2, 6, we'll just substitute 2, 6 here. Correct? So we'll
Oh,
calculate. So minus half times 2 minus 1, this becomes your x value. And 6 is my y value. So 2 times half times 6 minus 5. Is it clear to you? Calculate. So a minus 1, and this is 3 minus 5. Is that okay? And so
mm-hmm.
we get minus 2
Minus
as
2.
our point. And so we get the option B as the right option. Is this clear to you?
Mm-hmm.
Right.
And just a quick thing. So you got minus half of x because minus 2, you did 1 over x.
Yes, 1 over k.
Okay.
1
1
over.
over k.
So
Okay.
that becomes this.
And then the minus 1 because it's plus 1. Okay.
So
It's a lot of signs. That's why.
reverse. It reverse.
Yeah, yeah.
You get the idea?
Yeah, yeah.
So now we are also seeing how the image point can be figured out, right? Okay, now,
Oh,
many times in the test, what I could do is something like this. Think like this now. I tell you that the point on this function is minus 2 minus 2, okay?
okay.
Find the point xy on the function f of x. How will you do that?
Do I
You
have to
get my
work
idea?
backwards?
Backwards. So reverse calculation. So clearly, we'll still start with the
It's a
same
lot.
equation. You get my point? We'll
Yeah,
start
yeah.
with the same equation. Let's do this, okay? I just reminded of this is a very brilliant test question, okay? So we'll say we don't know what x is, correct? But we know that x value is minus half of x, right? So we'll write, we are given that the transform point, this is the transform point, correct?
Yeah. So that's,
Minus 2. Do you see that?
yeah.
And we don't know this value. Is that clear to you?
Oh, so it's just an algebra
So
equation.
we'll get minus 2 plus 1 equals to minus half x. Is that clear? So we get
Yeah, and then
minus 1 equals
solve.
to minus half x, correct? And we get x equals to minus 2. Do you see that? Oh, sorry, minus minus becomes plus, right?
Yeah. No, 2. Yeah.
Yeah, 2, right? Plus 2. Do you see that?
Mm-hmm. Mm-hmm.
Similarly, you could calculate y value also, saying that half of y minus 5 is given to us as
6.
minus 2.
No, minus 2.
So
Yeah.
we'll bring 5 here. So y equals to minus 2 plus 5, which is 3. And so y equals to 6. Is that clear to you?
Yeah.
So we got this point, backward calculation.
Oh,
So
I
many
see.
times in the test, they give you the point on the image and tell you to find on the original function. That becomes very tricky. So when you see your questions in your book, try to go
Mhm.
backwards and see how do we figure that out. Is that
Oh, okay. Yeah,
good
yeah.
idea, right? So anyway, we'll end up here and we'll take up inverse functions now. Is that clear?
Yep.
So
Yep.
can you just summarize what have you learned in transformation of functions in general?
Yeah, so we started off with the simple, well, so like the reflections that you have, the normal transformations, and usually at like GCSE level, they just show you a graph and then it's simple, like only like a horizontal translation, something really simple. But like as you get to year 12 and 13, they're using multiple of these transformations in like one question, which I saw. So when you had one of the questions, you had the stretch going on, the horizontal compression, and like a lot of the ones all together. The main thing I learned was, so if you had a graph, especially with the horizontal compression and stretch, they're really hard to deal with. So if you look at the origin first and you see where they move, that's how you determine whether it's a translation, because that's really like nice and straightforward. And in terms of like, what are they called?
Stretches and
Asymptotes.
compressions.
Well,
Yeah.
but when you're looking at asymptotes, you want to see if there's been vertical movements. Just look at them because they're always like the go-to for reciprocal graphs.
Yeah.
And then when looking at the horizontal stretches and compressions, first you look at them and see, the minus p and stuff, and then you check
This is
whether,
origin. Watch origin, right?
yeah, watch the origin, and
And
then you
second is
find a point.
asymptotes.
Mm-hmm.
They will directly give you the value of P and Q, the horizontal translation or a
Which is
vertical.
really nice.
Yeah.
Yeah.
Then look for a point, and point will give you the stretch factor. Simple as
Yeah.
that. You get the
And
idea?
if it's not, like if you, but like you said, if you take that graph and you put it on top of the other graph and you see they're not congruent,
Yeah.
then you know that it's a vertical one, so you deal with that.
Yes.
Otherwise, if you can see a movement, it's horizontal, and then go from there.
Very good. Okay. So now let's look into inverse of a function, right?
Yeah.
So last time we discussed about a function. Can you please read what I have written here?
Yeah. So function f is a rule that connects each input x to an output f of x.
Yes.
All possible inputs x are the domain of the function,
Hmm.
and corresponding set of outputs f of x is the range of the function.
Yeah. Yes. We also call this as codomain.
Oh, okay.
In many parts of the country, we call it. In many different cities, it is different, right? Yeah. So codomain is another word for range, same as range.
Okay.
Yeah. Okay. Now continue. So, okay, what we see here is a simple example where the rule is 2x plus 1. If I substitute different values of x, let us say if I take these four values as my input, then we can calculate as shown here in the calculations. Substituting minus 1 results in minus 1, substituting 0 results in 1, 1 gives you 3, 2 gives you 5. And in general, if I substitute a value a, what I get is 2a plus 1, correct?
Yeah.
So we
Yeah.
get our function output. Now we are today discussing what is inverse of a function. The whole idea is if I know what the output is, can I find what the input was? Do you see that reverse
Mhm.
calculation? For example, in practical cases, let us say you go to some place for some grocery shopping, for example, correct? And you say, well, apples, let us say, uh, let us say $2 for a bag, let us say.
Yeah. Yeah.
And you just work out, okay, so if I buy 5 bags, I have to spend $10. You get the idea.
Right.
So that is the direct calculation which we do. But the other way is, let us say if I have only $5 with
10.
me,
Yeah.
then how many bags do I buy? So we have to do the
Yeah.
reverse calculation, right? How many bags do I have to buy? That is the inverse of a function. You get the idea? So
Right. Right.
practical application, huge. So we have
Mm.
to see the function both ways.
Yeah.
So when we do the reverse way, it is called the inverse of a function, right?
Oh,
So in this
okay.
particular case, if I put these outputs back, do I get the input? That is the whole idea.
And if it works, you should do.
Yes, yes. So
Okay.
that is what we'll discuss today in our lesson on inverse function. Is that clear to you?
Yeah.
Okay. So basically what I'm trying to say here is if I reverse this motion, right? So earlier we went from left to right, but now we are interested that we know the outputs, correct? But what should be there inside my machine to work it out to get me the earlier input? Do you see that?
Yeah. Yeah.
Reverse. So that means what I'm trying to say is this new function in between, which is called the inverse of a function, right, will perform that operation that will give me inputs, which is x values.
Yeah. Yeah.
So it will work on the y values, give me the x values. This is the whole concept. Is that okay?
Uh-huh. Yeah.
We will also see that always it cannot give you the right answer. So always it will not be a function. That is what we'll also see. Okay.
Oh, yeah.
So what I've written here is inverse function is a function that reverses given function, right? So a function went in the right side, correct? And we got the values. And if I
Yeah.
reverse, this is called the inverse function. So basically, what is happening here is that if g of x is the inverse function, if let us say this inverse function is g of x, right? We don't know its equation yet. We have to figure it out. If g of x is the inverse function, then if g of x works on the function, we will get x. If g of x works on the y values, right?
Yeah. You get X.
You get s. So what I'm trying to say is if g works on y values, then what we get is x, correct?
Right. Right.
Earlier, we were saying when y works on the x values, what we get is f of x. Do you see that?
Yeah. Yeah.
So it is a kind of reverse. So when g works on f of x, correct? I could write like this, correct?
Yeah. You
We
get
get
X.
x. So if that is possible, in that case, we have a function, and this function is called inverse function. Is that clear to you?
Oh, okay. Do you always call the inverse function like f of -1, or do you do g of f of x?
Oh, okay, both ways. So,
Okay.
so that is the next statement. It says it is denoted as f inverse of x. Do you see that?
Oh,
That is how,
yeah.
right? And we can say f inverse of f of x is equal to x in the general, right? This is g of x. Is that clear to you?
Mm-hmm.
So we
Yeah,
can
yeah,
write g of x also as equal to f inverse of x. Is that clear?
yeah,
What then? We could
yeah,
write
yeah,
different function name, right? It depends
yeah.
how do we want to apply different function name or just inverse of that function. That means
Okay.
we are now interested in finding the input when we know the output.
Yeah, makes sense. Yeah.
Or
It just needs to be a different function.
for that output, what should be the input? Sometimes we targets are fixed. We know that is the target. Now, what should be the input?
Right,
Practical
right.
example. Therefore, inverse function has got huge application. Yeah.
Yeah, yeah.
So last time we calculated the outputs for a given input. Now I have to find some inverse function, and I found that this inverse function should be x minus 1 divided by 2. I will show you
Yeah.
how I found it, but let us say this is my inverse function. Let us calculate and verify. If my output is minus 1 and I put minus 1 in this formula, what do I get? Minus
Minus
1 is
2
minus 2, divided by 2 is
divided by
minus
2.
1. I get the same
Yeah,
value. Do you see that?
yeah.
If I substitute 1, 1 minus 1 is 0, and so I get 0, which was my input. If I substitute, in this case, 3, right? 3 is here, right? So 3 minus 1 is 2, 2 divided by 2 is 1, so we get the same input, which resulted into 3. Do you see
Yeah.
how these values are matching with those values, correct?
Hmm.
That means the function which now I have defined is the correct inverse function. Is that clear?
Oh, I
I
understood. Yeah.
verified my result, right? You will ask me like, how do you get this function, correct? So, how do we get this? There are many ways to do it. It's very simple. It's not very difficult. I'm showing you now four ways of doing it. Four ways, okay?
Okay.
Not one, but four. This is swap. Four ways, depending on what the case is. The first
Yeah.
way is very simple. We did work out some coordinate points, right? We said, well, if I put in minus 1, the output is minus 1. If I put 0, it is 1. I calculated the coordinate points, correct?
Hmm.
And I want to do the reverse of it. That means simple. Swap the coordinates. Coordinates minus 1 become same, but 0 1 will become 1 0. Do you see that? I swap.
Hmm.
So basically, what has happened is if
Oh,
I have x and y on the function, then it becomes y and
y,
y.
x. Yeah.
That is swapping, right? This is what I mean by saying swap. So this is method number one. If you are given a graph, coordinate points, list of values, just swap, and
Okay.
you are very clear. If it is a mapping diagram, well, this is like arrows going like this, correct? Just
Just
swap,
do it the
reverse
other
the
way.
direction, reverse the direction. You
Oh,
get from output in. Simple as that. You get the idea?
yeah.
Well,
Yeah.
always the points are not given to you. Well, if they are given, this is the best way of doing it, correct?
So it doesn't matter what graphs are given or anything, just literally swap the coordinates.
Yes. For example,
Oh,
let me show you. If a graph is given to you, let us say you find this point, right?
yeah.
This point is what for you? 1, 3, correct?
1, 3.
Then on the function it will be 3,
See.
1, correct? So you
Yeah.
go to 3 and 1. Do you see that?
Oh, that's really quick. Yeah.
And invariant points are those where x and y values are same. Those are called invariant points.
Oh, okay. So
So,
like -1, -1.
yeah,
Yeah. Doesn't
minus 1
change.
doesn't change. You get the idea? For a
Yeah.
line, you only need 2 points, correct? You're done.
Oh, I like that. Yeah.
So graph is easy, right?
Yeah.
Algebraic method is tricky. So we'll now see how do we figure this out, algebraic method, right? So we are given this function, which is 2x plus 1. I could write this as y equals to 2x plus 1 because that is the output, right?
Yeah.
The
Yeah.
whole idea now is to change x and y. So we will swap. So we'll swap input and output. So what I've done here is instead of y, I wrote x. Instead of x, I wrote y. Do you see that? I
Mhm.
interchanged x and y in my equation.
I get that. Yeah. Yeah.
And now we will isolate y because we
Oh, and
want to
then
find what
solve.
for that much, how can we buy? For this target, what should be the input? You see that? So we'll
Oh.
isolate y and we get y is x minus 1 by 2. So we can write this as inverse of this function is x minus 1 by 2. You get the idea?
Yeah. Yeah.
That is
Yeah.
slightly difficult.
I like
I
that.
will tell you the method which is normally not discussed in any book, and that is my method of reverse operation. We know from foundation basics that inverse is the reverse operation, correct?
Yeah.
Can you tell me, can you read this operation? When I say that y equals to 2x plus 1. If x is the input, what do you do with the input?
You times it by 2 and then you plus 1.
And what is the reverse operation? You go from here, you take
You
away
minus
1
1,
and divide by 2.
divide by 2. Oh.
Take away 1, divide by 2. What do you get? Minus 1 divided by 2.
Yours, yours took like 2 seconds.
Done.
Oh,
So it's
yeah.
a multiple choice question and you have to really do it. No
Yeah.
need to show the method, right? Sometimes.
Yeah.
Then do this
Okay.
reverse
Okay.
operation. You will think it was a line,
Yeah.
easy thing, and he did it. No, 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 no. Let me take a good. Okay, let's say y equals to 2 times x minus whatever. Don't worry about it. Plus 5. Let us see. How do we find inverse of this function? Can you tell me how will you do this function? If x is
So
the input, then what will you do first?
first you minus 5,
Hmm.
then you square
Square,
root.
square,
Oh,
and then you multiply, and then this, right? Let's
oh,
do
I
the
was saying
reverse
the
operation.
reverse.
Right? Now let's look into the reverse operation. First, I'll do minus
Yeah. So
5. So x
minus 5,
minus 5. And then I'm going
square
to
root.
divide by 2. And then I'm going to do the square root. Whenever you do square root, you write plus and minus.
Plus
And
1.
then I'll add 5. Correct? Done.
Oh,
Let me change these two values so that we have different results. Let me write 3 here. You see that? Did you see how I did the inverse?
yeah, but how come you didn't just like? How do you know what to do? So like I was going to do minus 5 first, then I square root, then I divide by 2.
So we're writing inverse because this is not a function. Is to the x value, you will do minus 5 first, right? Backwards.
Yeah.
And
Then I
then
thought you square root because I thought you just go in the same order it's written, not like jump around.
no. Reverse
Oh,
order. Reverse order is okay. Let's write the order first. Okay, let's write the order first.
so
So you're saying
times.
the order is first order is x minus 3. Is it okay? Then what do you do? Then you do x minus 3 whole square, correct? And then you do 2 times x minus 3 whole square, correct? And then you do
Oh,
2 times x minus 3 whole square plus 5, correct?
yeah.
So reverse operation is you have to go from here, correct?
Oh, minus 5 first.
So y equals to x minus 5. And then what will you do?
Divide by 2.
And then square root, correct?
Square root.
Plus minus. Whenever you do square root, plus minus, correct? And
Yeah.
then you do minus 5. Do you see that?
Plus 3.
I wrote, sorry. I wrote wrong. This should be, yeah. Plus 3, yeah, plus 3. I'm sorry. Sorry.
Yeah, that makes sense. Okay. So if
Yeah,
I write it like that first and then
yeah,
I do
last
the
time I
rest.
changed the values, but I changed at the wrong place.
Yeah. That's all right.
Yeah.
Makes sense.
So by doing the reverse operation verbally, you can actually find this solution. Do you see that?
Mm.
And
Yeah.
this is not a function. Do you see? Because we got plus and minus.
Oh, yeah. And functions can only have one because it's 1-to-1 or many-to-1. And that has 2.
Inverse may not always be a function. We have learned from here, right? We have also learned the 4 ways of doing it. And now let's apply this method, right? So let me take another example here before we get into that complicated square function, right?
Okay.
The square root is simpler.
Yeah.
The square root of x, normally it is very difficult. But anyway, so square root of x is shown here in green. Do you see that?
Mm-hmm.
So we learned many different techniques. We could do algebraically. Algebraically is actually finding x in terms of y. That is swapping. Is that clear to you?
Yeah.
So I could also do like this. I can square both the sides. Once I square both the sides, I get y square equals to x, correct?
Mm-hmm.
So I need to actually find what x is in terms of y. So I get x equals to y square. And so I do get the inverse of the function because now
Right.
I can say the value of f of y is y square, correct?
Mm-hmm. Yeah.
However, in doing this, we have done a mistake. And that is what I want to highlight in this particular example. The mistake here is when we defined our function square root of x, we know that x is greater than equal to 0 and y is greater than equal to 0, correct?
Yeah.
So when we find the inverse, the domain and range is swapped. So this y greater than equal to 0 now becomes the domain and x greater than equal to 0 becomes the range. Do you see that part? So we have to
Mm.
write that f inverse of x is x square, where x value is greater than equal to 0 and y value is greater than equal to 0.
I see.
If you only write
Yeah.
x square, then the parabola is no restriction on the domain, correct?
Oh, right. Yeah, yeah,
So
yeah.
there will be a mistake. So you have to see that it is not that algebra part which we do, but we have to
Mhm.
also take care of the domain and range. Okay.
Right, right.
Okay. And graphically, I've shown you how quickly we could do it. And you know, one square root is one, and therefore that will be the invariant point for this particular function.
Yeah, yeah.
Points we can say 4 and 2, right? So they really work out. And basically what we are trying to do here is we are reflecting the graph on a line which is y equals to x. So even if you draw a line y equals to x, then the invariant point will always fall on this line, correct?
Oh, yeah,
And
yeah.
the other
Because
two
it
points
doesn't
are
change.
reflection. Yeah, reflection on y equals to x will swap x and y. Is that okay? So you have
Yeah.
shown earlier that if I reflect on y equals to x, then x and y swap, right? This changes
Yeah.
the values. So that is what inverse of function is, strictly speaking. So reflecting
Hmm.
on this particular line helps us to find graphically the inverse of a function. Okay,
Yeah.
let's go further. Take up the next example. This is the parabola which I have just discussed with you. So we have y equals to x square graph here, right?
The green one.
The green one. And if I reflect this on y equals to x, what do I get? I get a parabola which is on this side, correct?
Yeah.
And vertical line test, it fails. And therefore, inverse of a
No
parabola
function.
is not an inverse function. It is. We found something inverse relation. We can
Yeah.
say there is an inverse relation, okay?
But not a function
Not a function.
because it fails the vertical line test.
Yeah. So
Yeah.
on the original function, it fails horizontal line test. And therefore, we know from the original function itself, it will fail
No.
vertical line test.
Yeah.
So we say, well, the parabola is fails the horizontal line test, and therefore it will not result into inverse function.
Yeah.
You can find the inverse, of course, which will be plus minus square root of 2.
So if it's not a function, then you can't write f of minus 1 of x.
No, no, you cannot write x now.
Okay.
Because you don't know if I put the y value as 4, you don't know should I go to minus 2 or plus 2. I'm confused.
Right. Right.
So
Oh,
it's not a
okay.
function. So we will not write. We'll just write f inverse indicate that we found the inverse, but this is a relation, not a function.
Not a function. Okay. Yeah,
Now,
yeah, clear.
I could have done one thing. I could have restricted this particular domain to only values greater than equal to 0. In that case, I would have been working only on the right hand side, correct? Now it
Hmm.
passes the horizontal line test, and therefore I will have a function which is inverse of the function as shown here, and the result will be f inverse x, which is equal to square root of x. Do you see that?
Yeah, yeah. So restrictions are a big thing
Yes.
because it would change the whole thing. It would make it a function when it's, yeah.
So the domain can be restricted to ensure that the inverse is also a function.
Uh,
Is that clear to you?
yeah, yeah.
So sometimes the question will be, how will you restrict the domain of this function to ensure that the inverse is a function? So look at
Oh,
the vertex. You could go left or right. Either side
right.
works. Is that clear to you?
Yeah, yeah.
So can you please read this question?
Yeah. So inverse of a parabola, f of x equals x squared, where x is less than or equal to 0.
Yes. This side I've taken this time, correct?
Yeah, yeah.
You find the inverse, and clearly the inverse is negative side of my square root function, and we can see that it is a function. Is this clear to
Yeah,
you? Correct?
yeah.
We'll quickly go through the next example. So now what I've done is I've taken a transform function, and we will see how do we find inverse of a transform function. So can you read this question, please?
Yeah, so consider f of x, which equals the square root of x plus 1. Part A, write domain and range of f of x. Part B, find the inverse of f of x. Part C, write domain and range of f inverse x. Part D, find the value of x for which f of x equals 10. Part E, find f of inverse 10. And then part F, how are the answers of part D and E related?
Correct. So let's begin with domain range of the function itself. So for simplicity, I've already given you the graph. It is a simple graph, square root of x, which is translated one unit to the left, correct?
Yeah.
So we have your graph here. Can you tell me the function domain and range, please?
So x belongs to real numbers where x is greater than or equal to -1.
Correct.
Y being greater than 0.
Correct. Now, what should be the domain range of inverse function? Tell me.
Um,
Square.
let's
Instead of
say,
x,
oh,
write
okay.
y.
So
Y
x greater
greater than.
than,
So you
oh,
start with x, of course. So you'll say
okay.
x
X
is
greater than equal to 0.
and y is
Y
greater than.
greater than equal to -1.
You see how
It's,
simple it is?
yeah, it's only because I was trying to picture the graph of the inverse, and that was a bit too complicated. So I was like, okay, just swap. Okay, got it.
So normally you'll find they will ask inverse of the domain range of the inverse function later. But first thing
Yeah.
first, write down
Okay.
domain of the function and then quickly write down domain of the inverse function. Don't waste your time.
All right.
Even if
Okay.
they're not asking, write it down because in my answer I have to write this. I have to include. Earlier you saw we got a wrong result if you don't write domain range.
Yeah.
That is a must, correct?
I
Now,
see. Okay.
you can do inverse of this function in many different ways. I like you to use words to find inverse. So f of x is square root of x plus 1. So what should be the inverse of this function? Tell me.
So x equals y squared -1.
Okay. So we'll change x and y. So f inverse x will be x square minus 1, correct?
Yeah.
And in addition, we'll write this domain and range that x is greater than or equal to 0. Is that clear to you?
Oh,
And
wait, how
y,
come? Oh, yeah, it should, because I swapped it. It should be x squared -1. I said y squared. Sorry.
yeah, it's
Okay.
same thing. First you do y and then replace y with x to get
Yeah,
this.
I see. Okay.
Yeah, that is also correct. That won't be wrong. Is that okay? Because
Really?
you will write that x as a function of y. You will write x as a function of y is y square minus 1. That is correct.
Oh, okay.
Which is
So it's the
same
same thing as
as
writing.
f inverse of it. Both are the same things. Is that clear to you?
Oh, right.
So don't
Yeah,
get
yeah,
confused.
yeah.
If I write x as a function of y, I'm talking about the inverse function.
Right. Okay.
But if you don't include this, that means you've
Then
done a
it's
mistake.
wrong.
Because x
Oh,
square has range all real numbers. You have to restrict the range, correct? And if you
yeah,
don't, it will be kind of like this. You get the idea? The
I see.
right half, the upper half of the square root function maps to the right half of a parabola. Is this clear to you?
Yeah.
And of course, how do we find f of x equals to 10? Can you part D? Can you read the question part D, please?
So find the value of x for which f of x equals 10.
How will
So
you
you
do this?
just
Yeah.
sub in 10 equals to square root x plus 1. Then you do 10 squared equals x plus 1. X equals 99.
Correct. And if you have to find f inverse of 10, what will you
So
do? You just plug
10
it in here, right?
equals x squared minus 1.
10 square minus 1, which is 9. Same thing, right? So it is one and the same thing. So when we find reverse, it is what value of
Oh,
x gives you that output. That is the definition, right? So this is a way just making it clear that this concept is clear to you. Perfect.
yeah.
So here is the graph which you can see, right? The green graph in this case is the inverse of the square root function which we talked about. And it is important to write domain and range of the function, correct? And we just figured out that the value was 99 for this particular function, correct? That brings
Yeah.
us to another very difficult question. I'd like you to see the question. It is consider the function x minus 1 divided by x plus 4. Okay, now can you tell me what is the domain range of this function?
Wait, on the graph is the blue one f of
On
x?
the graph, okay, don't look at the graph, please.
Oh.
Tell me from the equation what is not there in the domain, correct?
So x cannot equal -4.
Correct. So x is, I'm just writing in short, x is not equal to minus 4. And as far as the range is concerned, what do you write? Y is not
X
equal to,
cannot, y cannot 1. Yeah.
because that is the coefficient of your both, right? So that is my domain and range. If I have to find the domain and range of inverse of the function, what will I say?
So x is not equal to 1, sorry.
Yeah.
and y is not equal to -4.
Does it make sense to you?
Yes.
So first thing first, just
Okay.
write domain range for both, whether they are asking for it or they're not asking for it. Give this information. Things
All
will
right.
be much more clearer to you, right? You can
Yeah. Yeah.
verify that this domain and range gives you the shift in your vertical and horizontal asymptotes. Is that clear to you?
Yeah. Yeah.
And that is how clearly we could get. And now you said x is not equals to -4. That means -4 is the red graph, right?
-4 is the red graph.
Vertical asymptote.
Oh, yeah. Yeah.
So definitely that becomes my function. And the other blue graph has got the value at 1. Do you see that asymptote here? 1?
Yeah. Yeah.
Let me just draw a highlight. Do you see this, right? Does it match?
Yeah. Yeah. So it has to be that graph. Oh,
It
okay.
has to be that graph. Just to answer your
So
question.
yeah. So first work with that, then look at the graph. Otherwise, it's a bit
Yeah,
complicated.
yeah. Even if the graph is given to you, don't look at it.
Yeah. Okay.
It is
See,
waste
that's where
of
I fall
time.
in the trap. I always
Yeah.
look at the graph first and then get confused.
Time is so critical in the test.
Mm.
We should not get distracted. We should know when to do what.
Oh,
Question,
okay.
right? Domain range. Now we know that -4 belongs to the function vertical asymptote, right?
Right.
Where
Yeah.
is it? Yes, this one, this one. This is my function, right? So I'll write,
Yeah.
oh my God, this is f of x, correct? And as the other one, which is, that is my g of x. I'm saying transform function g of x. Is that okay?
Yeah.
Easy to do. Then you can easily describe and do all that. Now, my question is, which is a very difficult question here, how do we find inverse of this particular function? Can you help me with this?
I was trying to solve it algebraically right here.
Okay.
I don't know. Can I tell you the algebraic method?
Yeah, yeah. Tell me algebraic method. Yes, please.
Okay. So y equals to x minus 1 over x plus 4. I'm just
Yeah,
going to go through the steps.
yeah.
Then you said swap them.
Correct.
So x equals to y minus 1, then y plus 4.
Yeah.
Then you take the y minus 4 times it by the x. Okay, it's kind of long, but then in the end, you get it y
You are
minus 1.
correct. Yeah.
Xy plus 4x equals y minus 1. And then
Three together.
you take the y's common. So xy minus y equals -1 minus 4x. Yeah. And then minus 4x minus 1. And then y equals minus 4x minus 1 over x minus 1.
Beautiful. That is how you're going to do it. You could also take minus common and then write it down, right?
Yeah.
Now, that is all these steps. You want to understand the trick to do it without going through all this. So first thing first, as I'm showing you in my solution, it's important to go through the steps, right? We have to first look into domain range, right? Irrespective of the fact where are they asking. It is part C or D, doesn't matter. We have to answer all the parts, correct?
Yeah. Yeah.
First thing first. Now, and then we'll look into more details and answer the question, which definitely is finding the inverse.
Mm,
Finding the inverse, you had the correct way of doing it, and that is how we are going to do it. Is that clear to you?
yeah.
Now,
So is there no other way around that one? We can't, because that
you are
one
a
was
very
tricky.
you're a very bright student, right? So
Oh.
I have to give you the other answer also. Nobody is asking me this, right? So what I will do here is only for you. X minus 1 divided by x plus 4. So what I
Yeah.
do here is we have x minus 1 divided by x plus 4. The trick is something like this. I could write this as x plus 4. How can I make here plus 4? I want to write plus 4 here, right?
Hmm.
That means I will do plus 4 and minus 4. Is that okay? Very simple, correct? I can
Oh,
add and subtract.
yeah.
So that means I have a factor x plus 4 over x plus 4. And I also have a factor which is minus 5. Uh, I'll write here minus now. Minus 5 over x plus 4. Is that clear to you? So I
Yeah.
could write this as 1 minus 5 over x plus 4. Do you see how easily we got this equation?
Oh.
Now, from this equation, I've also got that this is one unit translation up. Do you see that? 1 unit translation?
Yeah, yeah.
Reflection on the axis. I can now describe the transformation of this particular function, which is also many times a very good question. So I am writing here 5 over x plus 4 plus 1. Do you see that?
Mm-hmm. Yeah.
Now, my question here is, I will include in this a part explain transformation of f of x. Do you
Mm-hmm.
understand?
Mm.
From parent function y equals to 1 over x. Do you see that? Now, this becomes a very difficult question. Not only to find the inverse, but in part xyz, I could always ask you, explain me the transformation. That's
Yeah.
very difficult.
Yeah.
After I do all this, now you know that it is reflected on the y-axis, correct?
Mm-hmm.
You could reflect on x also, because this minus could be down or up. So let's say vertical. So reflected on the x-axis, vertically stretched by a factor of 5, horizontally translated by 4
By
units to
four.
the left and 1 unit
Vertical
up.
translation up. Yeah.
That part.
Oh my god. That is a killer question. That's like four transformations in one. Oh my god.
Yes. And
Yeah.
doesn't look like from the given function that there could
No.
be. And who will imagine that's the vertical stretch by 5? Oh my God.
Yeah. Yeah. It doesn't seem right, but it. Yeah, but it
1 on 5
is.
is not there at all. And vertical. So it is a very difficult question. And normally, you should expect this as the one of the best questions on this particular topic. Is this?
Hmm. That seems like an A-star question.
It is. It is.
Yeah.
So I think we can end here, okay, today's lesson. So I think we have covered all the topics. You're ready to answer any question from your notebook. You understand?
Hmm. Yeah, I will
So,
definitely do that,
so
along with some questions that were on your slide. And
yeah,
together, I'll see if I can consolidate my learning.
sure. I'll also share with you the playlist on this so that you could
All right.
see
Okay.
what questions I have in my YouTube channel. So go
Yeah.
through them also. And in the next class or during the week, whenever, if you get stuck anywhere, just send them over to me. I'll help you out.
Thank
Okay.
you so much, sir.
And tell me, what did you learn today? How could you summarize this lesson on inverse function?
Yeah. So inverse functions, I learned actually quite a lot. Were there four ways of doing inverse functions or
Mhm.
finding them. So we looked at like graphically, we looked at algebraically, and then just with the coordinate points and swapping them. So I think, like you said, sir, it's good to know different strategies, because if I just know the algebra one, what happened if a question was just a graph? It's so
Mm.
much easier if I knew the coordinates instead of working it out, because that was a long process. So
Yeah.
just knowing them in your head, you can easily answer these inverse questions. And it's all about just knowing how, like when we started off the lesson, we were talking about from input to output, and getting those values. So a nice checking point would be, if you have your output, if you put it into your inverse function, which you calculated either through those methods that I said, and then you can get your input, that means that you've worked it correctly. So yeah, and then it's just about knowing, I think what really like struck me was that question with the parabola, and how, like, if you put the restriction, how they're so important, if it fails a vertical line test or something, but then if you put that restriction, then it won't fail any of those tests,
Yeah.
and it would just work like perfectly. So those restrictions again are also very important. And then with the inverse, if you find your domain and range for the actual function, and then you find the inverse function, the domain and range, they swap. So
Perfect.
again, it's a lot of swapping, but yeah, it makes sense because it is the inverse. So
Okay.
yeah.
That's great. So we'll end our class here. That was good learning and well done in
Yeah.
summarizing the key things. Okay, then. All the
I
best.
learned so much, so thank you so much. That was really helpful.